Okay, so this is 5.0, 5.5. I think I have it as 5.5 on my Google Classroom stuff, okay? So this is where we're going to start, and I'm just going to throw you guys into the fire here. I want you to use the strategies we've just talked about, synthetic division, to solve the polynomial, all right? So you're going to create your little bracket thingy, just like we talked about. You're going to have your blue numbers and your red numbers like we've worked through, okay? Ready? Go. To this point, it is equal to 0, but it doesn't tell you that 1 is a factor, right? Or is a solution. So far to this point, you've had one of two things. Either one, they've told you x equals 2, and then we make that our red number out here, right? Or they've told you that one of the factors is x minus 2. And then you use that to make your out the number, right? Well, now we're not going to have that. Okay, and really what you guys are saying about like guess and check, yeah, you could do that. You could just go pick a number out, try it, see if it works, and go. But we're going to be a little bit more educated about that, okay? And we're going to use this thing called the rational root theorem. So this is right in the middle of your notes page, okay? Your first blank you're going to fill out with this right here, rational root theorem. Okay? And then the second blank is this part down here. Now, I'm not going to have like a vocabulary quiz where you have to tell me rational root theorem is blah, 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 okay? But you need to know what it's called. Are they? I'm glad. Happy for you. I didn't make it. Okay, then this is at the very bottom of the notes. This is what it is. This is the important thing. Okay, and I'm really even going to say that this part right here is the important part. The factors of the constant over the factors of the leading coefficient. Remember, the constant is the number that's all by itself at the end of the polynomial. There's no variable attached to it. So on those two examples that we did from the homework, the constant was 6. Okay? The leading coefficient is that number at the very beginning, if it's written in standard form. And then we're dividing, right? When we say over, we mean divided by. Okay? So go ahead and flip your paper over. We're going to use this as our guinea pig. All right? 2x cubed minus 11x squared plus 12x plus 9. Okay? And how I do this is going to be very purposeful, okay? So the first thing that I want you to do, just so you have it in your notes, is I want you to label this as the leading coefficient. I'm going to put LC. And this is our constant. Okay, then we're going to go below the 2, and we're going to list the factors of 2. Not the multiples of 2, the factors. So what times what equals 2? 1 and 2. That's it. Then we're going to do the same thing for 9. So we're going to list all the factors of 9. So that's 1, 3, and 9. What the rational root theorem says is that we take the factors of our constant and place them over the factors of our leading coefficient. So here's how we're going to do this. I'm going to take these green numbers and place them in a fraction over the blue numbers. So I'm going to take 1, 3, and 9, and I'm going to put them over 1. So see how we put all the green numbers over 1? Then I'm going to repeat that process, 1, 3, and 9, but I'm going to put them over 2. All right. If that leading coefficient was a bigger number, let's say that it was 4. Let's say our leading coefficient was 4, we would do it again, right? Your hope when we're doing this is that you have a small leading coefficient. The best one is 1, because then you don't have to do a big long list, okay? Now, the reality These numbers right here that we listed first, 1 over 1, 3 over 1, 9 over 1, those are just what? Those are just whole numbers. We don't even really need the ones under there, right? But I wanted to show you that for this process, okay? I also want to alert you to the fact that let's say that this was a 3 here. What's 9 over 3? 3. So then if this were 9 over 3 and this was 3, those would be the same thing. So we would have a repeat, right? So with some of these, like on the second one that we're going to do, the list will be longer, but some of them will be repeats, okay? Then what we have to do with this is I'm going to separate these with commas. And then we want the positive or negative version of this. And that's an important part of this rational root theorem. What this gives us is a list of possible solutions. So our possible solutions here are positive 1, positive 3, positive 9. 1 half, positive 3 halves, positive 9 halves. Okay? Then it's also the negative versions. Negative 1, negative 3, negative 9, negative 1 half, negative 3 halves, negative 9 halves. So how many possible solutions do we have listed here? 12. Because I have 6 positive, 6 negative, right? So I have 12 possible solutions here. How many solutions am I going to actually have for this polynomial? 3. Right? So our list is pretty big. But what this does is help us kind of figure out maybe possibly what we could start with instead of just literally blindly throwing a dart at the wall. Okay? So now we're going to move to the next part where we do that, where it becomes just guess and check. So on the next part of your page, whether it's next to it or below it, we're going to start our synthetic division. And in this case, we don't need any placeholders because we don't skip any numbers. So 2, negative 11, 12, and 9. And then we get to pick what our red number is. Okay, now, this is a big tip here. When we go to do this, are we going to start out with 9 halves and try to do 9 halves and multiply by? No, don't do that. That's silly. Start out with easy ones, like 1, like positive 1. So let's do that, positive 1. Let's go through our process. Does it work? Remember what we talked about when we say, does it work? That means we get a 0 at the end. Did we get a 0 at the end? Because, I don't know. That should be negative 9. I think maybe I was combining one later with, so we get a 6 at the end. You should. Oh, yeah. There we go. Okay. So this doesn't work. So what do we do if it doesn't work? Cross it out. Do a different one. All right. So what's a different one you guys want to do? 3 sounds great. Let's do 3. This is why I put that 6 there, because I had this in my brain. Yay! We get it. 3 works. Woohoo! Okay, now can we stop, or do we need to do another level? We need to do 2 more. No, we don't. What was our degree to start out with? 3. It was a 3, right? Now we've done 1 level of synthetic division, so now we're down to a 2. So now I can write this out as a quadratic. So this would be 2x squared minus 5x minus 3. So now I have my depressed polynomial. Once we get it to this, we can factor it. Now, you could, if you really, really wanted to, you could do another level, and then you would solve in a different way. Okay, so like if you really wanted to do that here, you could, but it might take more guess and check and might be kind of annoying. So instead of doing that, we're going to factor. Okay, but the reality with this one is, I'm going to just shrink this and then zoom in. Can we factor that? No, because there are no factors of -3 that add up to -5. So here's what we have to do. And this has been kind of a new development for us. Here's what I want you to draw. Okay, and then I want you to put this in your notes. That's how we fill this in. So our B goes in the top middle, the A goes on the top left and right, and then A times C goes in the bottom middle. I would put it with the letters, just so you have it as a reference, and then we're going to do it with the numbers. That's what we're going to figure out. Okay, and that's what ends up being like how you factor it. So in this, it's going to be -5 here. It's going to be 2 here and 2 here, and then A times C is -6. So that's what it looks like for this one. Okay, so now instead of looking at this one and thinking about the factors of -3 that add up to -5, we're going to use this. And we think about the factors of -6 that add up to -5. So the factors of the bottom number that add up to the top number. So the factors of -6 that add up to -5. Well, 5 and 1, right? Okay, so it's going to have to be -6, +1. So we're going to put the -6 here, +1 here. Then we need to look at these two kind of like they're fractions. Can we simplify either of those? We can. Okay, the one on the left can be simplified. So it's going to be 1 over -3. Okay, and that becomes what I put in my parentheses. Okay, so the 1 is what's going to be attached to the x. So it's going to be 1x minus 3, which is really just x, right? And then the other one is going to be 2x plus 1. Yep, so then to solve, you set those equal to 0. So the whole like x method thing is a way of factoring when we can't factor like normal. So then we set those equal to 0. The first one's pretty easy, x minus 3. What minus 3 equals 0? 3, right? So x equals 3. For the next one, there's a little bit more work involved. So, yep. 2x equals -1, divide by 2, divide by 2. X equals -1/2. I'm going to be a little blunt, maybe kind of mean right now, but that on the right there, like we should be able to do that, okay? That's like 7th grade math. We need to be able to do that now. Okay, the other stuff is what's like my priority, okay? So we end up with 3 -1/2, and then we have 3 here and not 1. 1 didn't work, remember? So did we have 3 solutions? We do have 3 solutions. We're not going to graph this one. Okay, this is how we use the rational root theorem to solve a polynomial that has a degree greater than 2. Okay, now here's what we're going to do. This second one that's on your notes, okay, we're going to start this one, and then this is finishing it's what's going to be your homework. I'm not going to give you the whole worksheet tonight. Okay? Now, there's something right now that is kind of annoying. Using the rational root theorem, looking at the numbers that we have, what's kind of annoying? The 6. Yuck. Because the factors of 6 are 1, 2, 3, and 6. Factors of 4 are 1, 2, and 4. So we're going to have a long list for this one. So we're going to take the 1, the 2, and the 4, and we're going to put it over 1. And then what? Then we have to do it again. 1, 2, and 4, and put it over 2. Now, here's where I want to stop. Okay, I want you to notice something here. This one and this one. Okay, 2 over 2 is equal to what? 1. So this one, technically, you already wrote down. Because there's a 1 right here. 1 over 1 is 1, right? 4 over 2 is 2, which you already wrote down. So really, we don't need to include these in our list because we already accounted for them. Now, if you want to include them in your list and then cross them off, you can. Okay? Now you have to do it for 3 as the denominator. And then you do it for 6 as the denominator. You're going to have a lot. So we would do it again. 1, 2, 4. And now we have to use 3 as our denominator. Which all of those we got to keep. Then we do it again. 1, 2, and 4. Then we do it all with 6. Okay, now in this case, okay, 2/6 is 1/3, right? So we already have that one. 4/6 is 2/3. So we already have that one. Okay, so we end up with 1, 2, 3, 4, 5, 6, 7, 8. And then because we're going to do the positive and negative, 16 possible solutions. And that's where I'm going to leave you. The rest of this is going to be homework. Okay, what do I ask for on homework? Effort. I'm not going to be mad unless you come back with nothing else done. Like try. Okay, you should at least have like the synthetic division drawn up and you should have some effort shown, okay? That's what I want to see.